Question number 47 says that let the image of the line x minus 1 upon 3 equals y minus 3 upon 5 equals z minus 4 upon 2 in the plane 2x minus y plus z plus 3 equals 0 be L. A plane 7x plus py plus qz plus r equals 0 is such that it contains the line L and is perpendicular to the plane 2x minus y plus z plus 3 equals 0, that is the same plane written above. Then the value of p plus r plus 3q is. Students, if we analyze the diagram of this question, we can make a very obvious conclusion that this is a plane and this is the given line. Suppose it intersects at a particular point over here. Okay, so it is passing through this point. The mirror image of this line will be something like this, no doubt in that. So if there is a plane which is perpendicular to the given plane, let us say P1, the equation is 2x minus y plus z plus 3 equals 0. It contains the green line L. This is the line L. This is the given line L1. So L1 is x minus 1 upon 3 equals y minus 3 upon 5 equals z minus 4 upon 2 equals lambda. This is the mirror image line. So there is a plane perpendicular to P1 containing line L. Definitely it will pass through this point. Let this point be A. If it is going to pass through this point and it is perpendicular to the plane P1, definitely it is going to contain the line L1 as well. Okay, so we have the equation of plane in a single step is, let us take any point on this line 1, 3 and 4. So x minus 1, y minus 3, z minus 4. It is perpendicular to the given plane 2 minus 1, 1. It also contains L as well as L1. We don't need to find the equation of L. We can directly use the direction ratios of line L1. So we have 3, 5, 2 over here equals 0. From here you will get 7x plus y minus 13z plus 42 equals 0. In one line we have solved the question. Okay. So P is 1, Q is minus 13, R is 42. The answer of the question will be P plus R will give you 43 minus 39, 4. So 4 is the answer for question number 47. Let us move on to 48. Question number 48 says that the number of ordered triplets x minus y, y minus z, z minus x, where x, y, z satisfy the relation x into x minus 1 plus 2yz equals y into y minus 1 plus 2xz equals z into z minus 1 plus 2xy is. Students, we have three simultaneous equations. Let us say A equals B equals C. We always solve them by taking it equal to K. So let us say x into x minus 1 plus 2yz equals K, y into y minus 1 plus 2xz equals K, z into z minus 1 plus 2xy equals K, which will give you x square minus x plus 2yz, which will give you y square minus y plus 2zx. Subtract these two equations. This is equation number 1, this is equation number 2. Equation 1 minus equation 2, you'll get 0 on the right hand side. X square minus y square plus y minus x plus 2z into y minus x equals 0, which will give you x minus y into x plus y minus 1 minus 2z equals 0. So if you are getting this from equation number 1 and 2, then from equation number 2 and 3, you will get y minus z into y plus z minus 1 minus 2x equals 0. And from equation number 1 and 3, you will get x minus z into x plus z minus 1 minus 2y equals 0. Because all the equations are very much symmetric. So let us say this is equation number 4, this is equation number 5, this is equation number 6. Product of two terms in mathematics is 0. Either of one is 0. Okay. So the first possibility is that x equals y equals z. That means these three brackets are 0. So case 1, x equals y equals z. You'll get the ordered pair, which is x minus y, y minus z, z minus x as 0, 0, 0. This is the first solution. Talking about the other case, when the first bracket is not 0, when x equals y but not equals to z, that means y minus z is non-zero, x equals y is 0, x equals z again non-zero. So we have y plus z minus 1 minus 2x equals 0. X is equal to y already. So we have z plus x is equal to 2x plus 1, which gives you z minus x equals 1. Obviously, we have x minus y equals 0 because x I have taken it equal to y. Further, if z minus x is 1, that means z minus y is also 1. That means y minus z is minus 1. So from here, the ordered pair that we have for x minus y, y minus z, z minus x. So x minus y is 0, y minus z minus 1, and this is 1. So this is the first case. Similarly, you can take the case as x equals z not equal to y. From there, you will get one ordered pair. And ultimately, you can take y equals z not equal to x. From here, one ordered pair more. Just because they are talking about ordered pairs, you cannot shuffle these numbers at any cost. Okay. So 3 ordered pairs from case 2. Ordered pairs from case 2. And 1 ordered pair from case 1. 1 from here. So we have in total 4 ordered pairs satisfying this particular equation. We have one more possibility, that is x not equal to y not equal to z. When you solve the given equations under this condition, you will get no solution. So total number of solutions is 4. Okay. So let us move on to the next section, which contains multiple correct type questions. Starting with the next section, we have question number 49, which says that there are 3 coins C1, C2 and C3. C1 is a fair coin painted blue on the head side and white on the tail side. C2 and C3 are biased coins so that the probability of a head is K. They are painted blue on the tail side and red on the head side. 2 of the 3 coins are selected at random and tossed. If the probability that both the coins land up with sides of the same color is 29 upon 96, then what is the possible values of K? Students, we have coin 1, head painted with blue, and the probability is half. Tail painted with white, the probability is half. We have coin C2 and C3. Evaluation is same. We have head painted with red and the probability is K. Tail painted with blue and the probability is 1 minus K. Okay, because tail and head are exclusive and exhaustive events. So what is the random experiment being described in the question? The random experiment is that 2 coins are picked up from the set of 3 coins and the probability that they land up with the same color. So the same color can be blue. First coin has blue, second and third coin also have blue. The blue color can be red also if C2 and C3 come. Okay. Obviously, white color cannot be same because it is present only in coin 1. Okay. So that is the 2 cases for colors. Now let us talk about the possibility of blue, of 2 faces blue coming up. So 2 faces blue, how they can come up? C1, C2 plus C1, C3 plus C2, C3. If C1, C2 comes, there should be head on C1 and tail on C2. Similarly, if C1, C3 comes, head on C1, tail on C3. C2, C3 comes, tail on both of them. Plus, for red, C2, C3 as well as head. Okay. So students, out of the 3 coins available, the number of possible selection of 2 coins is 3. So the probability of every possible selection is 1 by 3. So 1 by 3 multiplied by C1, C2, 1 by 2 into 1 minus K for blue. C1, C3, 1 by 2 into 1 minus K for blue. Plus C2, C3, 1 minus K whole square for blue. This is the first part for blue color. For red color, it is again 1 by 3 into C2. For red color, head should come. C3 head should come. So K square. This value is 29 upon 96. So after simplification, we will get 1 minus k by 2 plus 1 minus k by 2 plus 1 minus k whole square plus k square equals 29 upon 32. I have cancelled 1 by 3 from both sides. So we have 1 minus k plus k square minus 2k plus 1 plus k square equals 29 by 32, which will give you 2k square minus 3k plus 2 equals 29 upon 32. Readjusting the terms, I'll have 64k square minus 96k plus 35 equals 0, which will give you 8k minus 5 into 8k minus 7 as the factors. Okay, equals 0. So there are two possible values of k. K is equal to 5 by 8 or k is equal to 7 by 8. So obviously C2 and C3 are biased coins with respect to the head side. Okay, so the two possible values 5 by 8 and 7 by 8. The answer of the question is option number A and option number B. Let us move on to 50. Question number 50 says that let P and Q be two non-zero real numbers, then the equation px square plus qy square plus r multiplied by 4x square plus 4y square minus 8x minus 5 equals 0 represents. This can be written as px square plus qy square plus r into taking common 4 and dividing it on the right hand side. I have x square plus y square minus 2x minus 5 upon 4 equals 0. The second equation is a circle for sure. Obviously g square plus f square minus c is positive. So this is a circle. Let us read options one by one and make conclusions about PQR. Okay. Option number A. Two straight lines and a circle. Circle is already there. How px square plus qy square plus r equals 0 represent two pairs of straight lines? We have only homogeneous equation over there and r is 0. Okay. Also, p and q must opposite signs, because if they are of the same sign, then it will be a positive number into x square, a positive number into y square equals 0. That will not yield any solution at all. There will be no locus corresponding to that. So that means A is correct. So if in order to represent pair of straight line, r should be equal to 0 and the product of PQ should be negative. Okay. B part. Two circles when P equals Q and R is of opposite sign that of P. One circle is already there. So for P equals Q and PR less than 0, QR less than 0. That means it will be something of the type, let us say P is equal to Q is equal to 1. So x square plus y square minus 5 or minus 4 equals 0. So definitely represents a circle, because the first condition of the circle is coefficient of x square equal to coefficient of y square. So P equal to Q. So this is also correct. C part. A hyperbola and a circle. Now how it is going to represent a hyperbola? Obviously PQ is negative and R not equal to 0. Because if R turns out to be 0, option number A will be correct. So C option is also correct. For R equal to 0, they represent pair of straight lines. For R not equal to 0 and PQ being the opposite signs, we will have the answer as a hyperbola. Okay. D option. Ellipse. So P not equal to Q. Because P equal to Q is the condition for circle, this is the condition for ellipse. P not equal to Q. Simple. And they are of the same sign. Obviously, they have to be the same sign, either both positive or both negative. And R is of the opposite sign that of P. That is also true, because that is also the condition of the circle over there. So only one difference in condition of circle and ellipse. P equal to Q for circle, P not equal to Q for ellipse. All the four options are correct. Answer A, B, C, D. A very, very simple question based on the basic definition of conic sections and the relation between the coefficients over there. Okay, let us move on to 51. Question number 51 says that which of the following functions are periodic? We have to analyze each and every option very carefully. Option number A. Fx is equal to signum of e power minus x. Students, e power minus x is a function which is always strictly positive. Signum of e raised to power minus x is equal to 1 always, because signum, if we enter a positive number, the output is 1. Okay, so we have a function as a constant function, and constant function are always periodic with no fundamental period over there. Okay, option number A is very much correct. Option number B. Option number B clearly does not satisfy f of x plus t is equal to fx. It does not satisfy this quantity at all, because it is x when x is rational, it is minus x when x is irrational. So let us say at x equal to 2 the value is 2, at x equal to 3 the value is going to be 3. So anyhow the values are not going to repeat for any particular rational number or for any particular irrational number. So if the values are not going to repeat, the function is not periodic. As simple as that. So B is wrong. Let us talk about option number C. For C we have fx as root under 4 of 4 upon 1 plus sin x plus root under 4 upon 1 minus sin x, which will be equal to 4 into 1 plus sin plus 1 minus sin. So 2 divided by 1 plus sin into 1 minus sin. So cos square x. So fx is 2 root 2 upon mod cos x. Definitely cos x is periodic, mod cos x is periodic, mod secant x is also periodic because mod cos x is in denominator. Definitely C is periodic. Talking about D, directly periodic because x minus greatest integer x is fractional part x and fractional part x is a periodic function with fundamental period 1. Adding 1 will not make any difference over there. Okay, so we have D also correct. Final answer ACD is the right one. Let us move on to question number 52. Question number 52 says that consider a function f from 0 to 5 by 2, 0 closed, 5 by 2 open, up to 1 by 2 open to 3 closed, defined by the function fx is equal to greatest integer x plus 1 upon fractional part x plus 1, where the symbols have the usual notations. Then which of the following are true? Students, we know that greatest integer x changes the value at every integer. We know that fractional part x repeats its value after every integer. So let us analyze this particular function from 0 to 1 separately, 1 to 2 separately, 2 to 5 by 2 separately. Okay, so we have fx as when x belongs to 0 to 1. If x belongs to 0 to 1, greatest integer x is 0. So 0 plus 1, numerator is 1, divided by fractional part x is x minus greatest integer x, so x minus 0 plus 1, so x plus 1. X belongs to 1 to 2. If x belongs to 1 to 2, greatest integer x is 1, so 1 plus 1, numerator is 2. Talking about denominator, x minus greatest integer x plus 1, so x minus 1 plus 1, that is x. X belongs to 2 closed, 5 by 2 open. Again, greatest integer x is 2. 3 upon x minus 2 plus 1, x minus 1. So we can easily draw these graphs, 1 upon x plus 1, 2 upon x, 3 upon x, x minus 1 in the given intervals. Okay, so let us have it. This is 0, 1, 2, 5 by 2. Rectangular hyperbola, 1 upon x plus 1 from 0 to 1. At x equals 0, the value is 1. At x equals 1, the value tends to half. So we have, let us say this value is 1. From closed interval to open interval, half. 1 by 2. From 1 to 2, let us talk about, again, rectangular hyperbola, 2 upon x. At x equals 1, value is 2. At x equals 2, value tends to 1. So from 2 to 1. Closed, open. Here it is closed. Then, the third part, 3 upon x minus 1, rectangular hyperbola, shifted 1. At x equals 2, the value is 3. X equals 5 by 2, the value is 3 upon 3 by 2, that is 2. From here till here. Students, range of this particular function is the open interval half to the closed interval 3. This value is 3. Obviously, it is 1, 1. Further, according to the codomain, it is surjective also. It has a few points of discontinuity as well as non-differentiability. So let us discuss the options. Fx is an injective discontinuous function. Correct. Fx is a surjective non-differentiable function. Correct. C part, let us hold on for it. D part, number of points of discontinuity of fx in its domain is 3. Domain is 0 to 5 by 2 open. So 1 point of discontinuity here, 2 point of discontinuity here. Wrong option. Then option C, minimum value of limit x tends to 1 minus fx. What is limit x tends to 1 minus fx? It is equal to 1 upon 1 plus 1, half, comma, x tends to 1 plus, so 2. The minimum value of these two is half, so left hand side is half, is not equal to f2. f2, students, is 3. Definitely half is not equal to 3. Okay, so correct. Final answer, ABC. A very good question based on functions. Okay, we have to analyze the behavior of greatest integer x as well as fraction part x in the different intervals over there. Okay, let us move on to 53. Question number 53 says that if alpha, beta, gamma are the roots of the equation x cube plus a power 4 plus 4a square plus 1 into x equals x square plus a square, then the minimum value of summation alpha upon beta plus alpha upon beta raised to power minus 1, that is beta by alpha. So summation means we have to consider all permutations, alpha by beta, beta by gamma, alpha by gamma, and so on. So we have, students, the cubic equation as x cube minus x square plus a power 4 plus 4a square plus 1 into x minus a square equals 0. Students, the summation of alpha by beta plus beta by alpha will be alpha by beta plus beta by alpha plus alpha by gamma plus gamma by alpha plus beta by gamma plus gamma by beta. This is what is the answer of the question. Okay, we have alpha plus beta plus gamma equals 1. We have alpha beta plus beta gamma plus alpha gamma equals a power 4 plus 4a square plus 1, and we have alpha beta gamma equals a square. So now let us smartly collect the terms. It is alpha plus gamma upon beta plus beta plus gamma upon alpha plus alpha plus beta upon gamma. Students, alpha plus beta plus gamma is 1. So this is 1 minus beta upon beta. This is 1 minus alpha upon alpha. This is 1 minus gamma upon gamma. So this will give you 1 by alpha plus 1 by beta plus 1 by gamma minus 3. And for 1 by alpha plus 1 by beta plus 1 by gamma, we can take the LCM. So we will have alpha beta plus beta gamma plus alpha gamma upon alpha beta gamma minus 3. So we have a power 4 plus 4a square plus 1 upon a square minus 3. So a power 2 plus 4 plus 1 by a square minus 3. So 1 plus a square plus 1 by a square. So a square plus 1 by a square, by applying AMGM inequality, we know that it is greater than or equal to 2. So the answer is greater than or equal to 3. That means the minimum value is 3. Okay, which means that option A is exactly 3, option B is 4, option C is again 3, option D is 4. So AC will be the correct answer for this particular question. Okay, option number A and option number C are correct. Okay, so now we have question number 54, which says that let f be a differentiable function on R and satisfying the integral equation integral 0 to x ft dt plus integral 0 to x t into f of x minus t dt is equal to minus 1 plus e raised to power minus x for all x belongs to real. Then we have to choose the suitable options about f0, f dash 0, f2 and so on. So we have to start with this equation, integral 0 to x ft dt plus integral 0 to x t into f of x minus t dt is equal to e raised to the power minus x minus 1. So students, in the second part of the integral, which contains the expression 0 to x t into f of x minus t dt, I am going to apply a plus b minus x property. So I'll get over here 0 to x, t will be replaced by x minus t, f of x minus t, so that will be f of t dt is equal to e raised to the power minus x minus 1. And this term is also here 0 to x ft dt. So separating the terms, we have 0 to x ft dt plus x into integral 0 to x ft dt minus integral 0 to x t ft dt is equal to e raised to the power minus x minus 1. So students, this is the equation in x variable. We can differentiate it with respect to x. So we'll have here fx plus here we will have product rule. So x into fx plus integral 0 to x ft dt minus, apply Newton-Leibniz theorem, x into fx is equal to minus e raised to the power minus x. So I have this factor getting cancelled. Over here, if I put x equal to 0, I'll get f0 is equal to minus 1. So if f0 is minus 1, let us continue this equation further. I have fx plus integral 0 to x ft dt is equal to minus e raised to the power minus x. Again differentiated with respect to x. So I have f dash x plus fx is equal to e raised to the power minus x. From here, if you put x equal to 0, I have f dash 0 minus 1 is equal to 1. So f dash 0 is 2. Further solving it, I have fx plus f dash x into e raised to the power x equals 1. So if I integrate on both the sides with respect to x, I'll get e raised to the power x into fx by parts is equal to x plus c. Again put x equal to 0. So I'll get 1 into minus 1 is equal to 0 plus c. c is minus 1. So ultimately, e raised to the power x into fx is equal to x minus 1. So fx comes out to be equal to x minus 1 whole multiplied with e raised to the power minus x. I have calculated f dash 0. I have calculated f0 also. f0 is minus 1. F dash 0 is 2. So this is correct. This is correct. f2 is e raised to the power minus 2. Directly put x equal to 2. So f2 is surely e raised to the power minus 2. So we have this option also correct. Final answer will be ABC. Okay. Just you have to follow Newton-Leibniz theorem, that's it. Okay. Let us move on to 55. Question number 55 says that the value of the integral dt upon t raised to the power 2 by 3 in brackets 1 plus t raised to the power 2 by 3 equals. So simply put t as x cube in order to get rid of the rational powers. You will get dt as 3x square dx. So integral 3x square dx upon x square into 1 plus x square. So very simple integral it is. Integral of 3 dx upon 1 plus x square, and that is 3 tan inverse x plus c. Definitely substitute back t. We have t equal to x cube, so x equal to t raised to the power 1 by 3. 3 tan inverse t raised to the power 1 by 3 plus the constant of integration. Only one option is correct, that is option number Bombay. Okay, let us move on to question number 56. This was a very easy one. Okay.